Alright, welcome back. We're going to be talking about releasing ducks from the clutches of an evil alligator. How exciting. Essentially, this problem is a kind of like a discrete math problem almost. We took it as a variant of a problem that we found from the 1974, the first ever ICPC college programming competition. So I think it's also called the Josephus problem. So if you're interested, just super compelled to read up on ducks and alligators and things like that. You can search it up, Josephus. Some guy named Josephus, I guess. All right, so just as we did before, we're going to read in our input with a scanner. I'm going to call mine KB this time because otherwise I'm just going to forget and type that anyways. And the first number that we read in again is the number of cases. So we'll just read that in like that. And now I'm going to use a little bit of a cheesy for loop to control our program this time. It's going to look like that. Essentially all this does, we don't need to initialize anything right here because we have our number of cases from the keyboard. And we're just going to go while cases are greater than 0 and subtract off a case every time. So it's really just the same thing as we did before, keeping a count, but just in a slightly different way. For each test case then, we're going to need to read in an N and an M in that order. So we'll just do that like this. And I feel like storing the ducks in an array list of integers, so we'll call that ducks. So yeah, essentially all we need to do is add all of the ducks to the list, and once we have them in the list, we're just going to need to count around the circle in the correct way and print out the one that we're on. There's a nifty little algorithm that will help us out with that. So the first part is just putting the ducks in the list. All we've done so far is make a list. We haven't actually put anything in it, so doing that, it's pretty straightforward. All you really have to do is add a duck, just like that. And since the ducks are just represented as integers, which represent their number in the circle, we can just add the integer that we're on, just like that. Okay, so now the actual meat of this problem involves knowing which duck is going to be in which spot. So the problem tells us that we want to look at the mth duck first. And since Java is zero-based indexing and the problem starts at 1, we're going to need to do a little bit of finagling to make sure that we're on the right one. So I'm going to start a for loop. I'm going to use current duck, and I'm going to set that equal to m minus 1. And again, that's just to fix the difference in the zero-based indexing between Java and between the way that our problem asks for it. I'm going to control this for loop for as long as ducks.size is greater than 1. And the tricky part of this problem is getting the current duck. So here, what I'm going to do is kind of use this Josephus algorithm that all of the discrete math people made up. And that is pretty straightforward. All you really do is add m to the duck that you're on and do a modulus around the size of the circle. So a modulus is just like a division that gives you just the remainder. So if you can imagine counting around a circle, then if you just divide by the size of the circle, you kind of end up with the position in the circle. So that might make a little bit more sense if you look at the picture along with the problem. I don't have that up right now, but if you can look at the picture, that might make a little bit more sense. So to actually write this out in code, we're going to set current duck equal to current duck plus m. And again, we have to subtract 1 just because of the way that we're doing the indexing. And do that mod, this is the modulus operator in Java, mod ducks.size, which will give us the number of ducks currently in the array list. Okay, so now all we really have to do, since if we did everything correctly up to this point, we know which duck we're on. We just have to print out the current duck, and our array list syntax for doing that looks like this. And again, just to fix the indexing, we're going to add 1 there, and then we will add 1 more space. So after each duck that we print, we just print out a space as well. And once we've printed out the duck, we are going to remove it as if the alligator ate it. So now what do we have? We essentially got the current duck at the correct spot in the circle, and we did that by looking at the current duck, adding m, and doing this modulus around how many ducks were left in the ring. And then we just printed it out and removed it. And since I went up until ducks.size greater than 1, we're going to have 1 duck left at the end. So I'm just going to print that out separately by doing ducks.get at 0 and adding 1. So this will work because we will have 1 element in the array list left at the end, so we'll just be able to access that by getting the 0th index and adding 1 again, just because the problem asks for this printed out using 1 based indexing. All right, and I will just close off my keyboard to clean up after myself, and then we will run this. Grab my test input. Looks like 8 and 4 and 7 and 5 are the ones that we'll try. So let's do 2, 8 and 4, and 7 and 5. So yes, these are the outputs that we'd expect. Yeah, essentially this is just the duck that is about to be eaten. So in this case of 8 and 4, the first duck to be eaten is the 4th, then the 8th, then the 5th, etc., etc. So yeah, that's pretty much it for this problem. Hopefully you were able to get along with this and save the ducks, because everybody loves ducks and nobody likes alligators. So yeah, it's also called the Josephus problem if you feel like looking that one up again, and it was a variant of a problem from 1974. If you have any questions, feel free to leave a comment or something below, and otherwise feel free to join us in the next video when we talk about strings.